Okay. So what we're going to do is already know that we can get electricity from fruit, fresh fruit in particular. So Steve is going to do the work for us, and we can figure out how we can maximize the amount of current or voltage, and we'll also talk about the difference between current and voltage as we get it going. So in front of you, you see some metallic objects. Would you identify some of the metallic objects that you have in front of you?
Please look into the camera, Steve.
The camera can't see him. It can only see his hand.
This appears to be copper, and this appears to be iron.
All right, so you've got copper and iron. Do you have any household objects ahead in front of you, too?
This appears to be a light bulb, and this also appears to be
Yes, it does appear. What else have you got there?
a pair of scissors,
Yes?
some steel wool,
Yes?
and a bundle of alligator clips.
Good, good, good. One more thing. Yes, we've got keys. So we've got a whole bunch of household objects there that might or might not help us in our investigation. We might have a spoon or a fork there in a minute if I remember to bring it over. So, what do we need in order to get a current? So, any hypothesis as to where the energy is coming from? Yes?
Ions.
Ions. What do you mean by ion?
Charged ions.
Charged ions.
cation
Now,
ions.
well, we've got solid copper and solid zinc. Will there be any ions there?
No.
No, because they're the solid, the metal, they're in the solid state. So where could we get some ions?
Liquid.
From the fruit.
Ah, okay, so you're suggesting that a fruit might have the ions we need, and then that can help make the ions we need. So, all right, to work. So Steve is going to walk us through. We don't know. We haven't tried this in advance. He's going to try to get some current for us. So while he's thinking, I'll just explain what we've got. We've got on one side, we've got a red ammeter. What does an ammeter measure?
The current.
Current.
Yeah, ammeter measures current, which is in amps. We also have a light-colored object with a V on it. And what is that?
A voltmeter.
That's a voltmeter, so it measures voltage. So think of voltage as the encouragement for the current to flow, and think of, that's a different type of meter. Okay, and think of ammeters as the amount of current. So we're going to look at both the encouragement for the voltage to flow and for the amount of current that's flowing. Okay, and so we've got an ammeter and a voltmeter. All right, so what Steve done is he's taken a strip of zinc and a strip of copper and he's placed them into this orange. So we're assuming that the orange has ions in it, that maybe the acid in the orange is eating away a little bit at the metal, and that's producing some metal ions, and that'll help us get our current, because we know we need we need ions for the electricity. All right, so when we use the old school meters, because they give us a nice visual effect there. And let's see what we got. Now, if you look at the top of the meters, they have a number of knobs on them. They read in different scales. So they can read from 1 to 3, or they can read from 0 to 15. So he's going to have to, you probably want to pick the most sensitive scale. So one is your ground, and then your other one is the one that's doing the reading.
This one also goes in the 3-volt.
No, it'll go in the ground, the other one. So that's your base level, and then, all right, so we get a tiny amount of voltage.
Is it really?
Okay, so we think it moved, so how can we test to see if it actually moved? Yeah, take it off and put it on again and see if we get the same.
Oh.
Yeah, okay.
Why did it
So,
come backwards?
so we're on the most,
We have a negative voltage.
okay, so what does that mean?
We're wrong poles.
Now, I told you that the voltage is the encouragement to move. So the negative voltage, what does that mean? No.
Going the other way.
Yeah, we were encouraging it to move in the opposite direction to what the voltmeter expects. Okay? So if we switch the clips, switch the polarity, we should get an encouragement to move. There we go. So there's an encouragement to move in the direction that the voltmeter expects. Really, there is no difference. It's just whatever voltage we expected, we either got the opposite direction to that or in the same direction. All right, so that's our encouragement to move. Can we get an actual reading? Let's get some numbers on there. So we're in your most sensitive setting.
Doesn't say.
Okay.
I can zoom
So that's at like 0. It's the bottom right here. Oh,
Yeah, it's the bottom one because we're in the most sensitive setting.
0.09.
Yeah, okay, so it's like 1/10 of a volt maybe, you
Yeah,
think? All right,
a
so
bit
that's
less
the
than a
reading. Okay, good. Now let's check the current. Now, what is voltage again? What can we think of it as?
Current over.
The yeah.
Yeah,
Encouragement to
but
move.
we're using other terms instead of telling us what it is.
The
Encouragement
amount
to
of
move.
electrons moving through a wire at a
It's not the amount of electrons.
It's the concentration.
All right, so now we're going to look at our tool. Okay.
You're supposed to run
This
it.
is physics.
Steve, you're supposed
Are
to
you
run it.
using the most sensitive setting?
Yeah. 5.
Now, 5 amps. Now, is there a more sensitive setting? It also reads in milliamps. It's hard to see.
50
Oh,
milliamps.
the
It's also, so we're interested in the milliamps. So
We're gonna
5
have to
amps
look
is
at
a
the
lot. If we go to 50 milliamps, that's only 100th, right? So there we go. And sometimes you've got to fiddle with the connections. Sometimes it's easier to screw it up a bit and then attach it underneath.
Would it be better if we plunge this deeper into the orange?
Well, let's see what happens. So we got a suggestion that if we put them deeper in, we might get a better reading. All right, so we get mini electrons flowing?
Anything happen?
And if we don't get mini electrons flowing, we should ask ourselves why.
More resistance.
Do we get any electrons flowing at all?
No. Wait,
There's
hold
too
on.
much resistance.
There could be a lot of resistance. Yeah, an orange is not just a solution on the inside. There could be a lot of impediment, literally resistance, but impedant for the electrons to flow. Maybe that's what's going on. So we're not getting a lot of current. All right, so we've got some other objects to try here. Let's see if we can, any of these other objects can produce a current for us.
Skizzers.
Should we go back to the voltmeter?
Okay, so that's, we got measurements off the voltmeters. That's what we do as scientists, right? We take measurements where we can. Alrighty.
Alright.
Now we've got some steel wool. Can steel wool make a difference here?
How would you make a difference?
How can we make a difference with the steel wool?
Rub
Yeah.
All right, suggesting rubbing what?
the copper and
Yeah, let's call them electrodes, for want of a better term. Yeah, let's go pull them out and let's give them a rub with the steel wool. What do we think the steel wool might be doing?
charge.
I'm not going to go with charging because I know that steel is iron and iron is a conductor. So we probably want to rub. I can't think that a conductor would charge something because if you had a charge, the conductor would let it flow away. So we're gonna have charging off the menu here. Rubbing something with a conductor cannot charge it because conductors conduct charge, so the charge would leave. What might we be doing with the steel wool? You probably need a more vigorous. I would pick one at a time and give it a little bit more of a vigorous cleaning. All right. So what might we be doing with the steel wool then?
Is it like when you rub balloons against your hair?
Okay, so that's charging again, and I'm not going to accept charging as a possible answer. Why?
It's solids.
You can charge solids. What do we know about steel wool? It's made of steel. What is steel made of? Iron. Is iron a conductor or an insulator? It's a conductor. Can you charge something with a conductor?
No, because
Why can't you charge something with a conductor?
Because conductors take the charge.
Yeah, it'll take the charge away because it conducts away the charge. So we can't be charging this by rubbing it. What are we actually doing?
we're actually decharging it, so it's more sensitive to charging. And
Well, you're still caught on the idea of charge. One of the things you have to do with a scientist is when an idea is rejected, you have to push the idea out of your mind so that a new idea can come in. So you're stuck on charge. So you have to get rid of charge. We're not charging the object. What are we actually doing? And when you understand what you're doing,
It looks like I'm cleaning it.
cleaning. Why might cleaning the object help?
Oh, impurities.
Okay, that's one possibility.
Some things might stop.
What are we asking? Why did we use the orange? What do we think the orange is doing?
it has
Eating away at the metal, turning it into ions. Where would those ions be, theoretically?
In the pure.
On the surface of the metal. So we may be cleaning away the ions so that we get new metal to turn into the ions to produce the charge for us. So now that you understand what you're doing, you're actually rubbing a little bit more vigorously because you understand, wait a minute, I have to clean any impurities or any oxidized metal off the surface, and hopefully that'll give us a bigger voltage. So when we get the electrodes cleaner, maybe we'll get a bigger voltage out of it. All right. So now, do we want to put them in the same holes or different holes?
Same one.
Okay.
Are you sure it was in that direction?
Does it matter?
No, it shouldn't. Really.
Ions have no hair.
Ions have no hair. Yeah.
All right, look at the voltage. How
Whoa.
much voltage are we getting now?
Bigger. More.
Yeah, can we get a number on that?
Steve, you gotta read it.
Yeah, the same person has to read the voltage each time.
It is approximately 1.23.
Yeah, so we're getting a lot more voltage now that we've cleaned, in our hypothesis that we've cleaned it away. Isn't that interesting? Okay. So it supports our hypothesis that what's happening in the surface of the metal is we're making ions. Those ions are releasing electrons, and now they're encouraged to flow. Maybe we'll get a current now. Let's see if we've got a current.
That was right here. Cleaning it. Yeah. I don't like these animators. Oh.
And we're still not getting a current. Okay, so we're not getting many electrons flowing, maybe not enough to measure. Now we have a different kind of meter here. This is called a multimeter, and it can read volts, it can read current, it can read resistance. So Gio's going to set this up here, and he's going to see if we can, we can attach. We can use a sensitive current setting.
The 200.
Yeah, that's 200 microamps, so that should be really sensitive. And we're going to maybe attach them to the two pieces of metal and see if we can...
No, it doesn't work like that, man. That's only in movies.
Clear.
Shove it into the ore.
No, we're getting a little bit, we're still reading, but not a lot. So we're not getting a lot of... Let's just... Oops. So we're not getting a lot of current. Okay, so what the electrons are, the meter's telling us something's happened if you see the surface in the meter, but we're not getting a lot of current. Now we're over in the volt section. Yeah, and there's our voltage. Attach again. All right, so we're getting some volts out of it, but we're not getting a lot of current. The electrons aren't encouraged to move, even though there's a potential difference. And our hypothesis is that we've simply got too much
Can we peel off the
resistance.
skin?
Of the orange. Do you think that might help?
Yeah.
And maybe you can try that, and maybe later on. Okay, so that was our demo. Well done, Steve.
Do we want to check the resistance? I want to see the resistance.